Okay, let's see the code using Komodo Edit. The first thing you should do is import the necessary modules. So these statements will always be at the top of our application code. You may know the modules you need for the program and write the import statements from the very beginning, or you may find out you need them along the way. Either way, you should always go all the way up and type your import statements there. Next, you should define a function that will wrap almost all the code of our application. Now, since this is a command line application, I decided to embed the code in a try except block that will handle any keyboard interrupt, meaning Ctrl+C, at runtime. As soon as the user presses this key combination, the exception that is raised by Python will be handled in an elegant way by printing a custom message and then exiting the program. Now it's time to write the code that will check the validity of the IP address entered by the user. As a side note, please notice that most of my codes will have comments to help both you and me keep track of what we're doing. You should always keep this in mind as a best practice. Now let's analyze the code below. Let's keep the while loop for now and concentrate on the next lines of code. The first thing to do is ask the user for an IP address. And for this, we have the row input function as we've seen earlier in the course. The string entered by the user will be stored in a variable called IP address for further use. Then it's time to dissect the value stored in the variable and split it by octets. This is done, of course, using the split method, having the dot as a separator. This will return a list where each element is an octet of the IP address. So if we enter a print statement here to print the value of A and execute the program, let's say print A, we should see a list. So let's save this and run the application. Okay, and this is the list I was talking about. Good, now let's delete this print statement to clear the program output. Now it's time to determine if the IP address is valid or not, and for this we should define the conditions for an IP to be valid. Well, let's think. First, it should have 4 octets, right? This is obvious, so our list of octets stored in A should have 4 elements. So len of A, remember the len function, len of A should be 4, as you can see here in the first condition. Now let's focus on the value of the first octet. First, notice that each element of A is a string. That's why we have to convert it to an integer when comparing to other values using the int function. You know that an IP address starting with 224 or a higher octet is a multicast address or experimental address. That would be class D or class E. Since we're interested in unicast addresses only, we're going to specify in the same if statement that A of 0, so the first octet in our list, should be between 1 and 223 inclusively. You also know that in this range we have 2 special cases. The addresses starting with 127 are reserved for loopback interfaces, so we must exclude them too. That's why the third condition is that A of 0 should be different than 127. The second special case is any address starting with 169.254. These are auto-assigned by Windows machines to interfaces configured for DHCP that are unable to contact a DHCP server, so we should add this condition too. So int of A of 0 should be different from 169, and int of A of 1 should be different than 254. Now, as a side note, notice that I used a pair of parentheses for each condition. I did this especially for better readability. We have a total of 5 conditions. So 1, 2, 3, this is the 4th condition, and finally we have this bigger condition, which is the 5th condition. Okay. Also notice that we have a logical AND between conditions. This means that the IP address entered by the user should meet all these conditions in order to be considered value. Because remember when we talked about logical operators, I said that when using an AND, all operands should be true in order for the expression to be evaluated as true, as a whole. So this if statement says if the octets in your IP address meet all these conditions, then it is a valid IP, and the program should break from this loop and execute the remaining code. Otherwise, a message is printed and the user should try typing the address one more time. This is the role of the continue statement right here, to redirect the user to the top of the while loop, so to the row input function. Now back to our 169.254 condition. Notice that this condition is made of two other smaller conditions, meaning the first octet should be different than 169 and the second octet should not be 254. But why did I use the OR operator between them? At first sight, you would be tempted to say that there should be an AND operator there, not an OR. Well, if I would have used AND between them, then I would have excluded some valid addresses too, like 169.200.1.1 or 10.254.1.1, because AND would have told Python that both operands should be true at the same time. So 169 and 254 would have been totally forbidden inside an IP address, which is not the case because we care only about the unique combination of 169.254. Okay, the final condition here states that octets 2, 3, and 4 of the IP address should be between 0 and 255 inclusively, which I think is pretty intuitive. Now let's actually enter several invalid addresses and see how Python handles them. So let's try a couple of addresses. Let's say 192.168.2, only 3 octets this time. Okay, this IP address is invalid, please retry. Let's try another one. Let's say 192.168.2.500. Okay, also invalid. Now let's try a loopback address. So 127.0.0.1. Okay, invalid as well. And finally, let's try 169.254.1.1. And this is invalid as well, as expected. Okay. Now let's try some valid IP addresses. We should be redirected to the next prompt that asks for the subnet mask. So let's try 1.1.1.1. Okay, great. Now let's try this one more time. Let's say 169.1.1.1. Okay, so this IP address is permitted. Also, let's try 1.254.1.1. Okay, also allowed. Great. I leave further tests for you to play with. Now for the subnet mask validation. First, I created a list with all the values that a valid subnet mask octet can take. This is the list right here. Next, using similar logic as before, meaning a while loop, asking the user for input, then splitting the mask octets and storing them in a list, and an if-else block, we can validate the subnet mask. Now, of course, the conditions in this case differ from the ones for an IP address. The subnet mask should also have 4 octets. The first octet should normally be 255, although you can allow lower values to be entered. And then the following 3 octets should have any of the values stored in the list we defined, so in the masks list, as long as any octet is larger than or equal to the next one. This is stated by the last condition right here, because you cannot have a mask like 255.252.255.0. See what I mean? Okay. So the logic remains the same, meaning if the mask is valid, then we break out of the while loop and execute the rest of the code. But if the mask is not valid, then we continue to the top of the while loop, asking the user to keep trying to enter a valid subnet mask. Okay, this was part 1 of our application. See you in the next lecture.